In this video, I will demonstrate an application of exponential functions. The problem is based on current data, and it is COVID-19 cases were first counted in the United States on February 15, 2020. On this date, there were initially 15 cases reported. After 45 days, there were 189,967 cases reported in the United States. Write an exponential model, a of t, which equals a sub 0 e to the kt, that approximates the number of COVID-19 cases in the United States after t days. Determine the exponential growth rate, k, to 5 decimal places. Then we want to use our model to determine how many cases the model predicts there will be in the United States on April 20th, which is 65 days after February 15th. The first thing we need to do is think about what our model requires. Our model a of t, which is equal to a sub 0 e to the kt, tells us that we need to know 3 different values to be able to plug in to find an unknown value. We know an initial value. There were initially 15 cases reported. We know the ending amount, 189,967, and we know a time that occurred, which was 45 days. If we substitute those 3 values, we can figure out what the growth constant is. So a of t, the ending amount, is 189,967, is equal to our beginning amount, 15, times e to the k, we don't know. Time is 45 days. We need to isolate the exponential expression, so we divide each side by 15. And that number is going to be a decimal value, so for precision, you can just leave that in the fractional form. So we get this 189,967 divided by 15 is equal to e to the 45k. To solve for k, we need to take the natural log of each side. So the natural log of the left side, that is the natural log of 189,996 all divided by 15. And the natural log of the right side, so the natural log of e to the 45k, is just going to be 45k. So we have natural log of 189,967 divided by 15 is equal to 45k. And so to solve for k, we can divide each side by 45. Then we can use our calculator to input the expression on the left. And when we do that, we are going to round to 5 decimal places. We get 0.20992. So our model then is a of t, which is equal to our initial value of 15 times e to the 0.20992 times t. So recall what this really means. This is telling us that the growth rate is about 21% for the COVID-19 cases in the United States. Now, to answer part B, we are assuming that this model continues, and we want to figure out, based on this model, how many cases would there be in the U.S. 65 days after February 15th. So that is, in this particular case, we want to find what is a of 65. And we do that by saying that's 15 times e to the 0.20992 times our input value of 65. And when we do that on the calculator, we're going to get approximately 12,645,983. So again, this is assuming that the growth rate that was initially determined continues beyond those initial 45 days that we had the data. Now, if you look at the current data, there's only 764,636 cases on April 20th. So clearly the model has changed, right? When we talk about flattening the curve, we are decreasing the growth rate of this virus.